Advanced Financial Modeling, Topic 4, Multi-Period Portfolio Modeling, and Learning Objective number 6. We're going to model the 4% withdrawal rate rule of thumb and also a random walk model of death using our new tools of the GBM random walk model formula and our macro. So I'm going to show you two models. The first one's a 4% rule, and the second one is going to be the random walk model of death. What's the probability I could live past the age of, say, 95? So let's start with the modeling the 4% rule. So what this is, it's a pretty standard rule of thumb that if you retire at about age 65 and you could withdraw about 4% of your portfolio value, have that be that first contribution. Say so you saved $1 million at retirement, you're age 65. 4% of $1 million is $40,000. So you withdraw $40,000 the first year, then increase that by inflation to keep your consumption up, and that should last you about 30 years. So the advice is never withdraw more than 4% of your portfolio value if you want your money to last 30 years. We can model that now with our new tools. So let's go to the spreadsheet and take a look. So I have this 4% rule. I have a real simple portfolio. You have $2.5 million. You are retiring at age 65. You're going to withdraw 4% of that, $100,000. Inflation's 2%. I've went ahead and calculated you're still going to have your portfolio invested using the 120 minus your age rule. So I have the mean and standard deviation of the portfolio all of your life. You can see it goes way out there, out to, well, it goes 30 years, out to age 94. And what I can do then is I have my withdrawal of $100,000. I have the withdrawal increase with inflation to maintain real consumption. And then I have my random walk model of portfolio. And it shows that the portfolio value each period is the prior value times 1 plus the mean plus the random z times the vol plus the negative withdrawal. So what you see here, every time you hit F9, you can go down to the bottom and see how many times at age 94, 30 years in retirement, do you have a negative balance. So how do I do that? I just need to run a macro that takes whatever's in cell 37.7, 37th row, 7th column, and puts it here, 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 here. This is the macro. It's called 4%. For I equal 1 to 5,000, next I and sum. Here's a countdown, and it's putting in cells 7 plus I9, which is going to be 8, 9, 9, 9, 10, 9, and so on, whatever's in 37.7. I'm not going to run it because I've already run it, and it'll take a little bit of time. But if I were to run that, you would get values that look like these. And then you could then explore the distribution by doing a simple calculation. Of those 5,000 possible portfolios 30 years after you retire, how many are greater than or equal to 0? Do a count if, that array of portfolio values, how many of those are greater than 0? And it looks like 79% of the time you'll have enough money to last 30 years. So it's a nice little model to give you probabilities that that 4% rule will work. On a light fun note, I also created a random walk model of death. You can use the random walk model on things other than portfolios, anything that's normally distributed. What if you expected to live to 85? Lifespans are normally distributed with a volatility of life of 7. So you're expected to live to 85 with a volatility of 7. This is conditional lifespan, meaning that you've already lived to age 65. You're talking to your financial planner. At that point, you have 20 years expected life from age 65 to 85 with a standard deviation of 7. Here is my random walk model of death. 85 years, that's B1, plus random Z times the volatility, 7 years. So every time I hit F9, I die at 86, 82, 86, 95, 78, 86, 70, ouch. And so this is the random walk model of death. If I were to graph 5,000 of these observations, I will get a normal distribution type curve. If you run a simulation of taking whatever's in cell 3-2 and putting it, say, here, 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 using this macro called sub-death, you can then count how many of these are greater than or equal to 95. What's the probability I'll live to more than age 95? And it turns out there's an 8% chance. Which then makes you start thinking, well, this back in this model said there's a 79% chance my money will last to age 95, but then there's an 8% chance I'll live past 95 or 92 or 5, whatever I had there. So you have to think about these. This is kind of a morbid idea of thinking about financial planning, but this is the reality of financial planning. Will you have enough money to last the rest of your life? All right, so that is the random walk model of death and modeling the 4% rule using the GBM model. So that's it. That's topic 4, multi-period portfolio modeling.